Hi students, we are going to look at redox reactions. Okay, so redox, the definition is made up of two words, right? It is a chemical reaction which involves oxidation, the ox, and reduction. So redox reaction, and it will take place simultaneously. So in a redox reaction, when one species is oxidized, the other will always be reduced. Okay, so question of the day is how do we decide which chemical reactions are redox reaction? We define it by 4 ways. Number 1, gain oxygen. So your sulfur gains oxygen to form SO2. So sulfur gains oxygen, so it is oxidized. Okay, whether something is oxidized or reduced, it will always be the reactants, your starting material. Okay, it is never the products which are oxidized or reduced. Okay, on the opposite side, if you lose oxygen, for example, your copper 2 oxide plus carbon gives you copper plus carbon dioxide. So your copper 2 oxide loses oxygen to form copper. So your copper 2 oxide is reduced. Okay, the next definition we are going to look at is lose hydrogen. Okay, so for example, your hydrogen bromide plus chlorine. This is a displacement reaction because chlorine is more reactive than bromine. It will displace your bromine. Okay, your bromine will be kicked out. Okay, so when chlorine displaces bromine, what happens is it will form hydrogen chloride plus bromine. So let's look at the hydrogen bromide. Your hydrogen bromide loses hydrogen to form bromine. Right, the HBr become the Br2. So your HBr is oxidized. Why is it oxidized? Because it loses the hydrogen. Okay, on the reverse side, your chlorine, Cl2, gains hydrogen to form HCl. So your chlorine, which gains hydrogen, is reduced. Okay, first two definitions are very simple. If you are taking pure science, there is no chance your school will test you this. Okay, loss of electrons is another definition of oxidation. So iron, solid iron metal piece will tend to lose electrons to form Fe2+. Okay, so this is the half equation that we write, where your iron loses 2 electrons to form Fe2+. Right, so this part you see the reactant side, right? The 2 plus the 2 negative, then you can get back something neutral. Right, if you cannot really see well what is happening, if you gain the electrons on the right side, you must lose the same 2 electrons. So this is like, for example, if I'm using sodium as an example, sodium is 281, right? This 1 electron will be lost. So when we write the half equation, we write Na give you Na plus electrons. Okay, and what's happening? Your iron or your sodium loses electrons to form Na plus or Fe2 plus. So the iron or the sodium is oxidized because losing electrons is oxidation. Gain electron is reduction. Okay, so when your ions gain electron, they will form something that's neutral. Right, I have a 2 plus here, I gain the electron, then you get something that's neutral. Okay, so copper 2 ions gain electrons, so copper 2 is reduced. Okay, so how do I remember this oxidation reduction? I remember it as oil rig for electron transfer. Oxidation is lose electron, reduction is gain electron. Okay, and then we have your increase in oxidation state. So in this example, the oxidation state, we can take it as the charge on the ion. Okay, so Fe2+, if in a reaction it became Fe3+, So what happens? You have a 3 plus, you gain 1 electron, then you can get back your 2 plus. So in this case, same thing, if you gain electron here, this part you are going to lose the electrons on your product or reactant side. Okay, so the oxidation state of Fe2 plus increases from plus 2 in Fe2 plus to plus 3 in Fe3 plus. So this is the standard way to write to explain out your oxidation state. Okay, oxidation state of the substance, in this case my starting material is Fe2 plus, increases from plus 2, right, in this compound, the Fe2 plus, to plus 3 in your product, the Fe3 plus. So increase in oxidation state, so the Fe2 plus is oxidized. Okay, and then decrease in oxidation state, we have your Cu2 plus electrons give you Cu. So this is also the same as gaining electrons, but in terms of oxidation state, we say we look at the charge. So this is plus 2, and it becomes this neutral compound, which is 0. Okay, so the oxidation state of Cu2 plus, the compound, decreases from plus 2 in the compound, the starting material, to 0 in the product side. Okay, so what is being reduced is the starting material, my Cu2 plus, that is being reduced. Okay, so this one, the definitions I always remember as gain, lose, lose, gain. Right, so gain, lose, lose, gain, it will be O, H, lose electrons, and you'll gain the oxidation state. Okay, so these two, gain, lose, lose, gain, and the oil rig will help you remember the definitions of your oxidation and reduction.